Hey guys, I'm going to go over one graphing exponential functions and one graphing log functions. And today in tutoring, number 4 especially got a lot of students. So I want to go ahead and go over number 4 as a class. Alright, so the issue with this one is, and this is the main issue that I saw, was that you thought that this was a log function. This is not a log function. Just because it has an e does not make it a log function. Remember, e has a value, 2.72, 2.82, whatever it is, I can't remember. But it has an actual value. It's like pi. So it still has a base. So the parent function for this would be simply e to the x. Everything else is transformations, okay? A stretch, a vertical stretch by 6. And then we're going to go left 4 because of that 4 in the exponent, okay? So now, through all of this, we can go ahead and do our parent table. If we're looking at our parent function, which is e to the x, we know that we're going to be using our x values because this is not a log function. This is an exponential function. Okay? It is. So now we can fill out our y by plugging in our x values in place. So we would get e to the negative 2 is, I'm sorry, I'm looking back at my work, 0.135. E to the negative 1 is going to be 0.3680. What's the value for e? Well, nope, that's not there. Anything to the 0 power is 1. E to the first power is 2.718. And then finally, e squared is 7.389. So this is the parent table we're going to be using to fill out our transformation table. Now, we said we had a stretch by 6 and we went left 4. So I'm going to take my x values and I'm going to subtract, it's the opposite, 4. And then for the y, I'm going to take 6 and I'm going to multiply my y values by 6. So, here we go. Negative 2 minus 4. Negative 6. Negative 5. Negative 4. Negative 3. And negative 2. 6y. We take all of our y values and we multiply them by, yay, by 6. Woohoo! So, this will become 0.812 2.207 6 16.3 and then 44.3. That function is increasing very rapidly. So the first thing I'm going to do, since it's an exponential function, I'm going to go ahead and sketch my asymptote. So my asymptote will be as follows. In an exponential function, what is my asymptote? It is my k value. Did we move up or down? No, we did not. So what we know is that there is a plus 0 on the end of this parent function. So my asymptote will be at the x-axis. That's 0. Ba-doop, ba-doop. That is my asymptote. Okay? Right there at the origin. So I can go ahead down here. Y equals 0. So now I feel comfortable on graphing my transformation table. So I'm going to use those ordered pairs and plot them up. Negative 6.82. That's very close. And you have to apologize. I'm going to have to apologize because it's going to be really close. Okay. -5, 2.203. So I'm going to go -5 up to 2. Again, we're going to zoom in. Here we go. -4, 6. -3 is off the graph. Okay, since -3 is off the graph, we have these 3 points to contend with. So it's hard to graph unless you know what you're doing. We know the asymptote is going to be 0, so I know my graph is going to hug that asymptote but never cross it. And now I can go ahead and do my very steep curve. And that is how you sketch that graph. From here, we can do our characteristics. What's my domain? A domain of an exponential function is always -infinity to +infinity. Your range, you read from the bottom. What's the first value hit? Whoa, Miss Smith, I hit 0. Absolutely. So it'll be from 0. And where's it going? It's pointing to +infinity. Okay. My x-intercept. Do I cross the x-axis? Look at the x-axis where the asymptote is. Do we cross it? No. So we will have no x-intercepts. Is this increasing or decreasing? It's increasing. Over what interval? It's always your domain, -infinity to +infinity. And then last but not least, excuse me, I still have 2. Just kidding. I was getting ahead of myself. My y-intercept. My y-intercept, you guys, you will take, you're going to sit there and try to tell me it's none. It's not none because eventually this graph right here is going to cross my y-axis. Okay? Eventually, it will happen. So you need to go and give me the algebraic calculation for the y-intercept. The algebraic calculation for the y-intercept is you take 0 and plug it in place of x. So, 6 times e to the 0 plus 4. You do all of that work, you just plug it in, that's all you have to do, and you'll get that the y-intercept is 0. I'm going to put it up here so I can have more space. 0, 327.589. That's my y-intercept. Now, last but not least, my end behavior. The first thing you need to ask yourself, is it reflecting? No, there's no reflection, Ms. Smith. Great. All you have to do is look at your domain and range. As x goes to -infinity, y goes to my asymptote at 0. Okay? And then as x goes to +infinity, y goes to +infinity. And that's it for my exponentials.